Now, before we begin to talk about how to name and write formulas for certain types of compounds, I want to first look at some patterns in the list here. So we have a list of formulas and then their corresponding names. So I want you to take a minute and I want you to pause the video and I want you to kind of come up with some of the patterns that you might see between how they're named and then how those correspond to the formulas. Okay, so some of the patterns that I see that all of these compounds end in "ide," with the exception of this guy. Otherwise, they all end in "ide." It also looks like if there's no subscript on the first element, it's just the name of the element. If there's a subscript on the first element, there's a prefix. And then the ending always has a prefix. Okay, so before we start to get into our list of rules, let's kind of dissect these examples just a little bit. So the first question I want to ask is, what were the types of elements in these compounds? So maybe we need our list again. What types of elements were in these compounds? So if we put our list back up, I see carbon and oxygen, phosphorus, sulfur, iodine, and bromine. I think that covers all of them that are in this list of examples. What types of elements are those? Are they metals, metalloids, or nonmetals? You should be saying that these are all nonmetals. All of these elements are up here in this corner of our periodic table, so that makes them all nonmetals. So if they are only nonmetals, what types of bonds are being formed? Well, we've already learned that if it's only nonmetals that are bonding, these are called covalent bonds. Or they're covalent compounds, but they're sharing their electrons. Okay, so let's take our commonalities, our patterns that we saw in the names and formulas, and let's turn these into a set of rules. So the first rule is that the first element is named with the element's name. So if the first element in the formula was carbon, we say carbon. If it was phosphorus, we say phosphorus. Our second rule is that the second element is named with an IDE ending. So if the second element is oxygen, it turns into oxide. If the second element is bromine, it turns into bromide. If the second element is iodine, it turns into iodide. So you're going to take off kind of the ending of the element and you're going to add an IDE to the ending. Okay? Our third rule is that we have those prefixes. And the prefixes correspond to how many atoms there are. So prefixes tell number of atoms. And then our last rule goes along with that. If the first element is just one, you don't use mono. So you never use mono with the first element. You use mono with the second, but you don't use mono with the first. Okay, so our prefixes. There's an easy place to find our prefixes. On your periodic tables, they're on the back. There's a box here down at the bottom that says covalent naming prefixes. That tells you the prefixes up to 10, which is about as far as we're going to need to go. So you have the prefixes on the back. You just need to use them when necessary. And then really the only time you don't use a prefix is with the first element if it would be mono. You just name it as the element. You don't have to put mono with it. So let's go back to our one oddball covalent compound. So iodine. So notice iodine is the only element in this compound. It's I2, and we just name it as iodine. That's because iodine is called a diatomic element. Which means when it's in its elemental form, it comes in pairs. There are 7 diatomic elements: hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. So anytime you see any of those elements listed on their own, they should be in pairs. So it should be H2O2, N2, so on and so forth. And when you see their formulas listed like this, it's just written as their element name. So anytime you see Br2, it's just bromine. Anytime you see the word bromine, it's Br2. Now, that doesn't mean these can't combine with other elements in different ratios. You can have 2 hydrogens combined with 1 oxygen to make water. They don't have to go H2 and O2. They can, but they don't have to. It's just when these are on their own. When they're alone, they have to be in pairs. And so those are the 7 that are called diatomics, and then they're not named as dinitrogen, it's just nitrogen. So that's kind of the exception to our rule, is with our diatomic elements. So at this point, we just need to practice. So let's put our rules actually to work. So I want you to pause. Using our rules that we came up with, I want you to go through these 4 formulas and write their names. Then I want you to go through the 4 names and see if you can write the formulas. Then go ahead and start the video again and see what you come up with. You can check your answers. Okay, so let's walk through these. So BRF would be, so bromine, and then it's on its own so it doesn't get a prefix. And then fluorine, which would be fluoride. So we're changing fluorine to fluoride, so we have the "ide" ending. And there's only one, so it gets a mono prefix. So bromine monofluoride. Okay, NO2, first element is nitrogen. No prefix, so we don't put any, or it's just one, so we don't put any prefix. Our second element is oxygen, so that's going to turn into oxide. And there are 2 of them, so we're going to put di in front. So nitrogen dioxide. Okay, example 3. Nitrogen's our first element. There are 2 of them, so I'm going to go ahead and put dinitrogen. Oxygen's our second element, so it's going to turn into oxide. And there are 5 of them. The prefix for 5 is pent. So it's going to be dinitrogen pentoxide. And then our 4th example, first element is hydrogen. There are 2 of them, so we're going to put dihydrogen. And then our second element is oxygen, so we're going to change it to oxide. There's only 1, so it's going to be mon. Monoxide just sounds weird, so we just say monoxide. So we have dihydrogen monoxide, which, by the way, is water. Okay, let's go from names to formulas. So carbon tetrachloride. So carbon, we know the symbol is C. Since there's no prefix, there's just 1. Chloride would be chlorine, so Cl. Tetra means 4, so we're going to put a 4 as our subscript. So CCl4 is carbon tetrachloride. Hydrogen, we should recognize as one of our diatomics, so we know it's just going to be the symbol H. And then it's going to have a 2 because it's a diatomic, so it's going to be H2. Example 3, sulfur trioxide. So sulfur is our first one. Sulfur is just an S. Oxide would be oxygen. And it has the prefix tri, so it's going to be SO3. Then our last example, silicon dioxide. So silicon would be Si. Oxide would be oxygen. Has a prefix of di, so it has a subscript of 2. Now none of these, the first element had a prefix, but if it did have a prefix, say this was disulfur trioxide, it would be S2O3. So that's all that would change. So that's how we go back and forth between formulas and names for covalent compounds.